Now see the example related to solenoid. Here a closely wound solenoid 80 centimeter long. So L is given to you, that is 80 centimeter. And now we can write here 80 upon 100 meter. Now this long solenoid has 5 layers of windings, 400 turns each. So the total number of turns we can write N is equal to 5 into 400. This is the total number of turns in the solenoid. The diameter of the solenoid is D is equal to 1.8 centimeter, but that is not required for calculations. Now current I is given to you 8 ampere. We have to calculate magnitude of the magnetic field inside the solenoid. So we know it, B is equal to mu naught Ni, where N is the number of turns per unit length. We can write mu naught into N upon L into I, and we know it, mu naught is 4 pi into 10 raised to power minus 7 Tesla meter per ampere into, this is 5 into 400 into 8 divided by here 80 centimeter, that will be 100 multiplied here up now, and in this case this is Tesla here. This 0 will get cancelled, and now this 8 and this 8 will get cancelled. So we will be getting 8 pi into 10 raised to power minus 3 Tesla when we calculate it. So this is the magnetic field due to solenoid inside it, and this magnetic field remains uniform inside the solenoid.